Let's have a look at this video first. Can you see the water is whirling? So can you see the water is whirling now? It's swinging around a point. It's rotating about a point. This is the curl of this velocity vector of the water. তার মানে ওয়াটারের যে ভেলোসিটি ভেক্টরটা সেটা একটা পয়েন্টের চারিদিকে সার্কুলেট করছে, রোটেট করছে. This is curl. Now it's time to define curl of a vector mathematically. So curl of V is a vector, and curl of V means del cross V. Del we have already defined, x cap del x plus y cap del y plus k cap del z. So this is by definition is the determinant of like this. So if we calculate the determinant, it would look like this. And we have just seen in the video of the glass and the water with some drops of ink within the water, we have just seen that the velocity vectors of water were curling or rotating around a particular point. So this is a picture of curl of a vector. Now what is the geometrical significance of a curl of a vector? Curl of a vector is a measure of how much the vector curls around or rotates about a point. So the three functions of like what we have defined in our divergence section, all the three pictures we can see that there is no rotation around a particular point. So all the three pictures corresponds to zero curl. Whereas if we see this is this point is having a substantial amount of curl, and as curl of V is a vector quantity, as we can see from this definition, the unit vectors are there. So this is of course a vector quantity. So we need to define the direction of the vector quantity. So if we think about anti-clockwise direction, so according to the thumb rule, if we rotate our hand like this, that is pointing upward to the direction of the page will be the direction of the curl of that particular vector. I mean that will be the direction of the curl itself. So here if we rotate anti-clockwise, so according to the thumb rule, our thumb will point into the z direction, that is out of the page, positive z direction, that is. And if these things will move clockwise, then that will be pointing in the negative z direction, that is downward from the page, away from the page. And this is suggested by the natural right hand rule. Imagine that you are standing suppose beside on the deck of a ship. Suddenly you can see a whirlpool on the ocean, in the ocean, and a whirlpool is a very good example of a region of a very large curl. Let's have a look that how we have calculated the curl of a vector. First we took a vector function v equal to y square x cap plus 2xy plus z square into y cap plus 2yz z cap. By definition, curl of V is the determinant like this. So if you calculate this determinant, this will turn out to be like this. I mean like this. Now let's differentiate. Del y of this should be equal to 2 only. It will not act on z. Del z will act on this only, not on this, because this is function of xy. Nothing to do derivative here. Same here, because this contains y and z and this is del del x. For this one, del del x of this one would be 2y. Applying del del x on this would be 0, and this is equal to 2y. So what we have came to, our result is 0 curl here. Let's construct a single vector for which both divergence and curl is equal to 0. That means if the function is v, then del of v, del dot v equal to 0, del curl of v is also equal to 0. Now you may think of a constant of, the divergence of constant is equal to 0, curl of constant is also equal to 0. But let's do something more interesting. If we say, if we take v equal to yz x cap plus xz y cap plus xyz cap, whenever we calculate the divergence of it, it will give me 0. And whenever we calculate its curl, you can check with your own, this will result in 0 also. Now let me give you another function. Say v equal to x y cap plus y x cap. You can check with this.